Hello students, welcome to my YouTube channel. Today I'm going to continue with the introduction to trigonometry, exercise 8.3, fourth main, sixth problem. So we have the problem as a square root of 1 plus sine A by 1 minus sine A equals to secant A plus tan A. So now here we are going to take LHS as it looks more complicated compared to the RHS. So now I'm taking LHS. So now we have LHS is equal to square root of 1 plus sine A by 1 minus sine A. Then I'm going to multiply both numerator and denominator by 1 plus sine A. So here we are going to multiply both numerator and denominator by 1 plus sine A. Now we have, so let me write this, the same thing. So what you're going to do is, we are multiplying numerator and denominator by 1 plus sine A. So we have like this, 1 plus sine A by 1 minus sine A. And what we multiplied? We multiplied with 1 plus sine A. So that I'm going to highlight with green color. So this is what we have multiplied, both numerator and denominator. See, if we cancel it, we get back the previous expression. Okay. So we got the previous thing. Okay. Now, what happens now here? Now it is like a plus b into a plus b. Okay. So instead of a, you have 1. Instead of b, you have sine a. Okay. Now 1 plus sine a dot plus sine a will become 1 plus sine a the whole square. And denominator, it is like a minus b to a plus b. That is a square minus b square. So that is also identity I'm using. So what we write, so let me write this next step here. So we have 1 plus sine a the whole square by 1 minus sine square a. And now what I do is 1 minus sine square a is nothing but cos square a. So let me write how we got this cos square a. Let me show you. So we know that this sine square a, okay, plus cos square a. So cos square a is nothing but equals to 1, correct? Now suppose I'm going to transpose this sine square a to the other side. So we will be left out with cos square a on the left hand side, and I'm going to get it as 1 minus sine square a. Okay. So that's why I'm replacing 1 minus sine square a with cos square a. Okay. So now we are going to use, let me show you. In my next step, I write it as equals to, so I'm writing it as 1 plus sine square a by 1 plus sine the whole square by cos square a. So now cos square a is nothing but here 1 minus sine square is replaced. Then I'm going to distribute these square roots for both numerator and denominator. So that means I'm going to write like this. So you'll understand. So let me show you. So here I'm distributing the square roots for both numerator and denominator. Then if I take the square root for this whole square, the square and square root gets cancelled. So it's get neutralized. So now this square and square root gets cancelled. Here also the same thing. Here cancel this square and square root. And here also the same thing, square and square root and square thing, and going to cancel. Then in my next step, it becomes 1 plus sine a by cos a. So it becomes 1 plus sine a by cos a. Now we can split this fraction into two parts. That is, I write it as 1 by cos a and sine a by cos a. So here cos A, you can keep it as the common denominator. So I can write like 1 by cos A plus sin A by cos A. So let us write. So we can write it as 1 plus cos A, 1 by cos A plus sin A by cos A. So this one, 1 by cos A is nothing but secant, okay? It's equal to secant A plus, and sin A by cos A is nothing but tan A. So this is nothing but it's equal to RHS. So I'm going to write it as equal to RHS. So that is our answer. So we got from LHS we started and we got the RHS. Okay, hence proved. Next we have the problem. Let me take the next problem. I have the seventh problem here. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equals to tan theta. So here obviously we take up the LHS part. I'm taking the LHS now. And here we are going to take sin theta in the as common factor in the numerator, and I'm going to take cos theta as a common factor in the denominator. Okay. So let us write that. So it's equal to. So here we are writing the fraction. So we have in the numerator, I'm writing it as sin theta into 1 minus 2 sin square theta. And denominator, you're going to write it as cos theta into 2 cos square theta minus 1. See here, when you multiply this, you should get back the previous expression. See here, sin theta into 1 is sin theta into minus 2 sin square theta will become minus 2 sin cube theta. Similarly, cos theta into 2 cos square theta becomes 2 cos cube theta. Cos theta into minus 1 is minus cos theta. Okay, so that is how we are taking the common factor. Okay, next, what I do is I'm going to write the sine square theta as 1 minus cos square theta. And this denominator will be retained as it is. Let me show you what I'm doing. So here I'm writing this numerator as, so I'm writing it as sine theta into 1 minus 2 into 1 minus cos square theta. And denominator, I'm going to retain the same thing. Okay, like this. Here, see, we are replacing the sine square theta with 1 minus cos square theta. Next thing, what I do is, I am going to, excuse me, then I am going to open this bracket. So we have in the numerator, I write it as sine theta. So now I write it as sine theta into 1 minus, see, minus 2 into 1 is minus 2, minus theta minus is plus, so 2 cos square theta. Okay. And denominator, we are going to retain the same thing. So cos theta into 2 cos square theta minus 1. Then it's equal to, I'm going to write this one. So 2, my 1 minus 2 is minus 1. So that is 2 cos square theta minus 1. I'm going to get in the numerator. Okay. So sin theta into 2 cos square theta minus 1. Let me write the fraction here. So I'm going to get the numerator as sin theta into 2 cos square theta minus 1. Similar. And this denominator, I'm going to retain as it is. So cos theta into 2 cos square theta minus 1. Now, this 2 cos square theta minus 1 and 2 cos square theta minus 1 gets cancelled. So we are cancelling this. We are left with sin theta by cos theta. And So you know that sin theta by cos theta is nothing but tan theta, right? So I'm going to write it as tan theta, which is nothing but is equal to RHS. So this is equal to RHS. Okay. Now I take up the next problem. Problem number 8. We have sin A plus cosecant A the whole square plus cos A plus secant A the whole square equals to 7 plus tan square A plus cot square A. So it's equal to, now we have LHS. We have LHS. I'm going to take the LHS part. So we have sin A plus cosecant A the whole square plus cos A plus secant A the whole square. The next one, what I do is, now here we are going to use the identity A plus B whole square. So A plus B whole square is A square plus 2AB plus B square. Or you can write it as A square plus B square plus 2AB. So I'm going to use that. Okay. Now I'm write it. Let me write it. So here it's equal to, so I have the first thing A square. So that is sin A the whole square is sin square A. We have, then I have cosecant the whole square is cosecant square A, and then 2AB. 2AB means nothing but 2 sin A into cosecant A. So 2 sin A into cosecant A plus, then again we have cos A plus secant A, we need to expand that. So cos A the whole square is nothing but cos square A plus secant A whole square. So secant A whole square is secant square A plus, I'm going to write next 2AB, that is 2 cos A into secant A. Okay. Next, what I do is, I'm going to rearrange the terms. So what we are going to, let me write it. So rearranging the terms we had. Okay. So I'm going to write the sin square A and cos square A together in my next step. So sin square A, I'm going to write my and plus cos square A. Then I'm going to write plus cosecant square A. So we're going to write that plus cosecant square A plus secant square A plus then 2 sin A into cosecant A plus 2 cos A into secant A. Okay. Now this is nothing but, now it's equal to, now we know that sin square A plus cos square A is nothing but 1. So 1 plus this cosecant square A, I can write it as 1 plus cot square A. So I'm going to write it as 1 plus cot square A. So 1 plus cot square A. Let me write that. 1 plus 1 plus cot square A. And then similarly, the secant square A can be done as 1 plus tan square A. I'll write it as 1 plus tan square A. Then sin A into cosecant A, they get cancelled because it is reciprocal actually. So I'm going to write it here like this. Let me show you. It is 2 sin A into 1 by sin A. So this cosecant A can be done as 1 by sin A. 1 by sin A plus similarly 2 cos A into secant A can be written as 1 by cos A. Okay? Cos A. So the sin A cancels, cos A also gets cancelled. So let me do that. So here sin A I'm cancelling, cos A is getting cancelled. So you will be getting it as, so now it will be like 1 plus 1 plus, okay, and this 2 cos square here, right? 1 plus 1 plus 1, here also 1, total 3, right? See here, this one, this is also 1, and then here also I get it as 1, and here already in this part you have 2, and again this part 2. Totally you get how much? It will be 7, right? 7 plus cot square here. Over here, we could write cot square here. You'll be left with cot square here. Cot square here plus, and then tan square here. So finally, it is equal to RHS. So that is so hence proof. So finally, we proved that sin plus tan square plus cot square what we got it. Next, I have the problem. Ninth one. So here we have cosecant A minus sin A to secant A minus cos A equals 1 by tan A plus cot A. So now here will be first considering LHS. So we're going to consider LHS. Now we have LHS as cosecant A minus sin A into secant A minus cos A. So it's equal to, then what I do is this cosecant A is nothing but 1 by sin A. So I write it as 1 by sin A minus, then again sin A we have sin A. Okay. I'm going to enclose it with bracket. Enclosing with bracket now. Then secant I can write it as 1 by cos A. So 1 by cos A. Then minus, again we have cos A. Here all this also I'm going to enclose it with bracket. So let me enclose it with bracket. Then I'm applying cross multiplication. Let me show you how to do cross multiplication here. Now sin A, you can write it as sin A by 1. So that is sin A by 1. And cos A also, I can write as cos A by 1. Then, so here, first you're going to multiply the denominator. So sin A into 1 is sin A in this part. So I'm showing you here. So you'll be getting it as sin A. Sin A into 1 is sin A. And 1 into 1. So you get it as 1 minus. And then you get it as sin A into sin A is nothing but sin square A. So you get it as sin square A. Now I'm going to put the bracket for this. Similarly, okay, the same way, and I'm going to get cos A in here the denominator because cos A 1 is cos A and 1 into 1 is 1, and in here instead of sin square A, you'll be getting that cos square A. Okay, so we got 1 minus sin square A by sin A and 1 minus cos square A by cos A. And we have already used this identity. 1 minus sin square A, you can write it as cos square A, and 1 minus cos square A, you can write it as sin square A. So now I'm writing it as, I'll show you. So it's equal to numerator. I'm writing it as, so here I'm going to write it as cos square A by sin A, and then this is not even bracket you have. So bracket you can open, you can just write into also. And similarly, 1 minus cos square A. So 1 minus cos square A is nothing but sine square A. Okay. So we can write it as sine square A by sine A. Now we can cancel off sine A with the power. So I'm cancelling here. So here when you cancel, you completely cancel the sine A. Whereas here you'll be cancelling only the power part. So just to make it as 1. Okay. Minute. So here and here cos A. So here it is cos A. And here also I'm going to cancel this cos A, completely cancel. And here you're going to write it as 1. Okay. So you'll be left out with cos A into sin A equal to cos A into sin A. So this is the value we got. Next, I'm going to take RHS because I didn't get the what is required. See, actually, we need to get 1 by tan A plus cot A. So what I do is I'm going to now take the RHS part. Okay. So now I'm going to take the RHS. So we have the RHS, which is 1 by tan A plus cot A, which is equal to, let me write the fraction here. So we have the numerator as 1 and tan A, you write it as sin A by cos A. So tan A, write it as sin A by cos A, and cot A is nothing but cos A by sin A. So write it as cos A by sin A. Then we are going to apply the cross multiplication method for this whole denominator. Okay. So now we write a fraction here. So let me write 1 here. And again, your denominator, you'll be having a fraction. So cos A into sin A, you'll be getting in the denominator. So write it as cos A into sin A. And here sin A into sin A is nothing but sin square A. You get, so you get sin square A. And cos A into cos A is cos square A. So you're going to write it like this. Sin square A plus cos square A. Because sin A into sin A is sin square A. Cos A into cos A is cos square A. Or it's equal to, then you have the next step as, so let me write it. So here, writing the fraction, the numerator you have 1 and denominator you have sin square A plus cos square A as 1 and you'll be left out with, so cos A here, okay, 1 by 1 by cos A. 1 by 1 by cos A is nothing but equal to cos A. That's equal to cos A into sin A. So my next step, write it as first cos A into sin A. Now we got both LHS and RHS as cos A and sin A. So we can write like this. So therefore, LHS equals to RHS. So that's our final answer. Next, I have the 10th problem. 1 plus tan square A by 1 plus cot square A equals 1 minus tan A by 1 minus cot A the whole square equals tan square A. So here you're going to equate the first expression, the first part, you're going to equate it with tan square A. So you're going to start with this first expression and you'll be getting it as, finally upon solving you should get as tan square A. Similarly, you're going to take the middle term, middle one, and then you're going to solve it and get the answer as tan square A. So we are taking this, so I'm going to consider 1 plus tan square A. So consider, so we have the 1 plus tan square A by 1 plus cot square A. And we know that 1 plus tan square is secant square A and 1 plus cot square is cosecant square. So I'm going to take it as, let me write that secant square A by cosecant square A. So 1 plus tan square is secant square A and 1 plus cot square is cosecant square A equals to. So now we know that secant square A is nothing but 1 by cos square A, right? So secant square I write it as 1 by cos square A. And what is cosecant square A? Cosecant square is 1 by sin square A, right? So let me write. Okay? Because see here secant and cos are reciprocal of each other. Similarly, sine and cos cosecant are reciprocal of each other. That is how you need to remember. Then what we do is here when we have this division of fractions, so I'll tell you one technique. So first what you do is here you're going to first write the numerator part. So we have the numerator as 1 by cos square A. So I'm going to write it 1 by cos square A. Next what you do is this is division sign. So fraction when you have this, when you have a bar, big bar, that is a division sign. So this division sign, when it is changed, okay, it becomes multiplication. So you're going to write the multiplication sign and simultaneously you'll be taking the reciprocal of 1 by sine square A. So 1 by sine square A upon reciprocal, you get it as sine square A by 1. Okay. So now you got it like sine square A by cos square A. So now here, so got it as sine square A by cos square A. So this is nothing but tan square A. So it's equal to, we could get it as tan square A. Okay. Next thing, what I do is, I'm going to consider the next one, which is 1 minus tan A by 1 minus cot A the whole square, correct? So we're going to consider, this time I want to consider, so next term we are going to take this one. So it is, so we have this 1 minus tan A by 1 minus cot A the whole square. It's equal to, now here we have to be very careful about this. So tan you write it as sin A by cos A and cot A you write it as cos A by sin A. And you have to retain the square also. So you could write like this 1 minus sin A by cos A and cot A you write it as cos A by sin A the whole square. Okay. Next what you do is, so here you want to write it. In my next step, I write it as, so now here you can apply the cross multiplication method. So same way. So 1 by 1 I write it here. Here also write like this 1 by 1. Okay. Now in this part, just consider only the numerator here. Okay. And if you look at it, numerator 1 into cos A is cos A and 1 into cos A is cos A and 1 into sin A is sin. Okay. So similarly, you're going to do for the denominator also same way. So 1 into sin A and 1 into cos A, that is sin A minus cos A by 1 into sin A sin A. So here we get like this. We have got like this here, cos A minus sin A by cos A and sin A minus cos A by sin A. Okay. Next, we can cancel this. Yeah, what we do is I'm going to distribute this squares for all the terms here. So that means to say, I can write like this. So I'm going to write it this way. So I write like this, cos A minus sin A the whole square by cos square A. And here sin A minus cos A the whole square by sin square A. We can cancel this cos A minus sin A the whole square and sin A minus cos A the whole square. See, both of these, no, when you expand it, you will be getting the same answer. So that is why I'm going to cancel this. Because, so just to make a note of it. So here, you must note that a minus whole square and b minus whole square, both of them will be, you're going to get the same answer. Okay, because a minus whole square is a square plus b square minus 2ab. And here also b square plus a square minus 2ab. So both will be, you'll be getting the same answer. That is why we can cancel that. Okay. Next, what I do is, so here we get in the numerator as 1 by cos square. Yeah. and denominator we get it as 1 by sine square A. So we're going to get it as 1 by cos square A by 1 by sine square A. Okay, because this 1 and 1, it's nothing but it's a result of the cancellation. Okay, next here we can write, I told no. So when you have divisions of fractions, first you write the denominator. So 1 by sine, 1 by cos square A. So 1 by cos square A into, then you get, you're going to write the reciprocal of the denominator. So I write it as sine square A by 1. Okay, or it is nothing but you have sine square A by cos square A is equal to sine square A by cos square A, which is nothing but tan square A, is nothing but moderated as equals to tan square A, or hence proof. So we can write that. Okay, so we proved both of these two terms finally equating to tan square A. So that's it for now. So we will be meeting again for the next session. Thank you.